we have to move swiftly on, and Pepijn's there already. Pepijn is from Software Improvement Group, and and he's going to share his insights on green software and help you get a grip on your carbon footprint. Is that right?
Excellent. Yeah, thank you, Adam. That's right.
Go ahead.
So,
can I have an applause for
Thank you so much for being here today at the Green IT Adoption Track. Much appreciated. So my name is Pepijn van Kamp. I work for Software Improvement Group, where I facilitate our green software research. We do that in collaboration with some of the Dutch universities in a research engagement that is called Let's Go. And we'll actually show some of our results here as well. But before I do that, I wanted to share a couple of statistics on why this is actually a relevant topic today, right? So when people think about carbon emissions, often you envision, for example, factories that are fuming. But what many people don't realize is that the energy grid globally emits 40% of all carbon emissions. If you then look at, for example, data centers, you see that data centers globally use about 4% of the global electricity. And that this is actually expected to grow to like 10 to 14% in 2030. So that's really growing massively. What we also see is if you compare that, for example, to the aviation industry, that IT is already surpassing basically that. So that's really, really scary in that sense. If you look at different organizations, you see that those have very different carbon emissions or different carbon footprint. If you take, for example, Starbucks, you see that if you look at, for example, the IT organization of Starbucks, that's only 1% of their carbon emissions, while, for example, their dairy farms produce the majority of carbon emissions. However, for digital organizations, that is completely different and completely the other way around. You see some digital services companies, like, for example, banks, report carbon emissions of up to 50% for their IT departments. If you then look, for example, at some statistics from Datadog, so that is a company that performs log aggregation, which runs on many servers, they indicate that actually 83% of the container spend is wasted on idle resources. Now that kind of sums up why we have a severe problem here and why it's important to invest in reducing the energy consumption of software and lowering carbon emissions. So how does software then actually emit carbon? Going really rapidly through this. So of course we have let's see if this works. We have the energy grid itself, which is powered by different sources of energy. In the Netherlands, for example, our grid is mostly powered by gas plants, with on top of that solar and wind energy. But if you look, for example, at other countries, this is completely different. For example, France runs primarily on nuclear power, and a country like Sweden runs, for example, on nuclear with hydro in addition of that. And this means that basically the energy grid emits very different amounts of carbon at different locations on our planet, but also during different times of the day. For example, in the Netherlands, when the sun is shining, our basically carbon intensity of the grid is much lower than, for example, at other times of the day. So that is what we look at on the energy grid side. Then we can also look at the data center side, where we primarily look at the effectiveness of the data center itself, which is often explained as the power usage efficiency, which is basically the ratio of the energy consumed by the servers divided by all energy consumed by the entire data center, also including, for example, cooling, networking, power distribution, these kinds of aspects. And on the other hand, we can also look at the power consumptions of the actual servers in this data center. And then last but not least, there's the aspect that is typically called embedded carbon, which is mostly about the manufacturing of, for example, servers, but also the devices on the client side and the carbon that was emitted during the production of these devices. So then in a nutshell, you get basically the four aspects that you can take into account when looking at carbon emission of software. Yeah. So at SIG, we use ISO standards to provide basically a structured analysis to our clients of specific problems. When it comes to green software, we use the ISO 21031 for software carbon intensity, which on a high level basically describes three aspects of software carbon intensity. The energy efficiency, which is basically about reducing the amount of energy that is consumed by the software. The hardware efficiency, which is about the footprint of the hardware and, for example, the amount of years you use to amortize the embodied carbon that was produced during the manufacturing of this hardware. And last but not least, the carbon awareness, which is more about making software aware of the different intensities at different times of the day or different locations, so that you do more work when energy is clean in your software solution. Yeah. So at SIG, basically what we do is we do a lot of back of the envelope calculations. So there's a lot of software measures that you can take to make your software consume either less electricity or emit less carbon. But what many organizations struggle with is to bring these things into practice because there is no data on how these measures contribute to lowering, for example, the amount of carbon emitted. So this is basically what we do. We provide back-of-the-envelope calculations of all kinds of measures. And here you see a nice example, which is about time shifting. This is a strategy that is used to, for example, do more work during times where there's more renewable energy. If you look, for example, at the 2024 data for the Netherlands, you can basically see that if you were to run your workloads at a specific time of day, the most efficient time of day in the Netherlands is actually 11 o'clock in the morning, you would have basically reduced your carbon emission by 36% by just doing that measure, running your batch jobs in that time frame. If you were to use a more advanced scheduling mechanism, for example, using some of the forecasting data, for example, from data providers like electricity maps, we see that you could actually reduce carbon emissions by 43%. So this really gives some insights into what is possible with this specific strategy. And we do that for other strategies as well. So then very briefly looking at the location intensity. So there's very large differences between running your software on different locations on this planet. We see, for example, that the difference between running your software in Germany, for example, the AWS Frankfurt data center versus running your software in AWS Sweden, the northern region, that this is a factor of times 17 lower carbon emissions, just because Germany runs mostly on coal, while Sweden runs on nuclear and hydro. So there's huge differences here as well when it comes to the running your software on a different location. This is a more advanced scenario. So what we also do is provide a back-of-the-envelope calculation, for example, for lift and shift scenarios, where we use a couple of assumptions. This is a scenario where we migrate an on-prem project server, I'd like to call it, to a cloud environment and then apply different green cloud practices to it to see like what happens then actually to the yearly emissions of the software and what happens to the cost. So I'm not going to each and every detail, but what's important to understand is it's based on assumptions, but it gives you a high-level view on what are the potential reductions and how do they actually stack up. And you see that actually different measures that you can take stack up quite rapidly. For example, lifting and shifting to cloud could already reduce carbon emissions with 87% for the server configuration that was used here at hand. Moving to a green cloud region, for example, the Sweden region, is another 92% reduction. Maybe picking another one using a different chipset, like for example, using ARM instead of Intel x64, is then another 38%. So these things add up really quickly. And one of the things we learned is that if you ask, for example, leadership on what is the typical reduction that you could achieve, that people think that maybe 10-20% reduction in carbon emission is possible, but it's actually more along the lines of 50 to 70%, and sometimes even up to 90%. What we also do is look, for example, at programming languages. This research was also referred to in the keynote by Luc earlier. The famous example here is, for example, that Python does a lot worse than the other languages. Well, there's obviously a lot of nuance to that, right? So Python is an interpreted language. We see that it uses 38 times more energy than, for example, Java. However, Python is a language that's often used in data science, and many of the underlying libraries that it uses are actually compiled in C or C++ code. So those actually do perform well. What we see in our research within our Let's Go project is that if you take Python but you actually compile it ahead of time, that it performs much better, and that at that point it only uses twice as much energy as Java. So there's still a lot of room for improvement in that sense. What is good to be aware is that we rarely advise clients to rebuild their entire system in a different technology just because of this. There's a lot of other risks that are involved there as well. But what we do recommend is when building a greenfield solution is to take the aspect of sustainability into account and then also look at the programming language. And it might be that you still go for Python because of its domain-specific capabilities in the data science domain. But if you were to maybe build an application that is more related to business logic, then maybe another programming language is a better fit. So that is how we basically look at this issue. Then very briefly on our research. So we look also specifically at the software itself, the source code. What changes can you make there, and how do they impact the energy consumption of software? Here you see an example where we look at Java code and we focus on the usage of data structures. Here we detected basically legacy data structures like the old vector and the old hash table, and what would happen if you replace them by their newer versions, the array list and the hash map. And in the open source system that we tested this on, we saw a reduction of 17% in energy consumption just by making these changes, refactoring these instances. And these are actually single line changes, right? So really relatively straightforward. We also had a real world case that we investigated on our own software, where we basically found an analysis on a very large system that took almost 10 hours to complete, which indicated basically wrong usage of a data structure that led to an inefficient algorithm in that sense. And we saw that the changes that are then made to resolve this issue, which are again very small changes in source code, that those are not really an optimization, but rather a paradigm shift in the effectiveness of such an algorithm. And these kinds of issues we also basically bring into our SIGRID platform so that we can detect them automatically. We have currently a set of about 300 unique rules to pinpoint all kinds of inefficiencies in source code and basically bring that to development teams faster using static analysis. So that is already part of our SIGRID platform today. In our assessments, we again use the ISO 21031, and we have mapped that to 8 system properties that are related to source code, architecture, deployment, infrastructure. And this helps us to basically do a structured evaluation of a software system. And basically how we do that is by looking through the lens of sustainability by design. And there's all kinds of green software patterns that you could apply. And basically what we do is we look in a very structured manner at the architecture of a software system to indicate like, is at every layer of that software system the correct measure in place that you would expect in a sustainable software system. And these measures, they can live at different levels, right? So for example, they could live in code, like we saw in the examples mentioned before, but could also be in the UX design, in the front end, for example, pagination, adding that as a strategy could help. If you look more at the architecture perspective, you would expect, for example, a simplified topology, not a microservice architecture where each microservice calls all other microservices, for example. At the data level, we typically look at the database, indexing that is present there, compression of data at rest, all these kinds of aspects. At the network level, a low-hanging fruit is typically enabling HTTP compression. Somehow this always goes wrong if you check for these things. So we basically check all these things in a very structured manner to get an idea of the architecture of a system and where the issues in such a system then live and what development teams then can do to improve from that situation. So that is the goal of basically the assessments that we do for our clients. And that brings me actually at the end of this presentation. So green software engineering might feel like yet another quality aspect that we as engineers need to take care of, but it's good to be aware it is often aligned with existing business objectives like reducing costs, making software faster, making software more scalable, preparing for existing compliance, not on the slide, but also the reputation of your organization, both internally, looking inwards at the company, and also externally. That's basically our summary here. Thank you for your attention.
Thank you very much for your time. Bang on time as well. Well
okay,
done.
good. Had to speed up a little bit, sorry.
It's a multifaceted approach, amazing. One little line of code can have a huge impact. One very small thing can have a huge impact.
Exactly.
Incredible, isn't it?
Yeah,
To think that.
That's really fascinating.
But you take a real 360-degree approach to improving IT's sustainability, for every aspect. I saw Viva nodding away there. Is it all the stuff you're doing, or is there something? Was there anything new?
Pepijn has a very thorough